So let's talk about writing formal lab reports. I'm going to use an exemplary but not perfect lab report so you can see some of the qualities of a great report, or listen to me on how to make it great, but how to write them without spending all your time doing so. So here's what you need in a formal lab report, and you should find this in a template that's available to you. The title, report date, your name and other information that the teacher has required. An objective, which is a short statement of what you're trying to learn from nature, from the regularities in nature, and how you're going to measure it. Materials, procedure, and very important to have a little safety paragraph so you confront specific hazards that might be encountered in the experiment and how you're going to control them. Then qualitative data. Then quantitative data, always reported in tables with units at the top. Sample calculations of how you use the data to get to your results. Any graph that you might have, which frequently will be after a results table that has units and deviation from the expected results in it. So you can switch off graphs and results for logical progression. Then a conclusion that answers the question you raised in your objective. And finally, extensions, which would be comments on your accuracy and precision, and any other things that you might have thought of during it. That's not where you put "I liked the lab." That's immaterial whether you liked it or not. Okay, so let's start on the title. And the students were reacting hydrochloric acid with measured amounts of baking soda, and they were finding the mass of sodium chloride produced. There should be a 1-to-1 mole ratio there. So you can see here the title of the report and a date, and in this case period, and a balanced equation. Now you'll notice that the balanced equation has a subscript correctly on sodium hydrogen carbonate, but not in the title. That's one of the few subscript errors in this particular paper. You simply, to get a subscript, you highlight the numeral, choose font in your word processor, and click on subscript. Google Docs is kind of easy to work with because if you highlight it and then push Control, comma, that does the same thing, and then you push Control, comma again to get out the subscripting. And you'll notice they spelled the chlorine or chloride with 2 capital letters, and that's a big no-no. The objective. Simply said, use numerical data to predict the amount of product produced and to compare the calculated value to the amount actually gotten and find the percentage yield. It's brief, it relates what you're measuring, and asks a question that can be answered in the conclusion. Then the materials, procedure, and safety. This is very well done by this particular student. The procedure is not too long, and the safety concerns and how you're going to meet the safety issues are given. Qualitative data, you would want information on that, like he lives here, like he gives here, but you might want to also have color, odor, and shape of the original crystals of the sodium hydrogen carbonate, and the very distinct odor of hydrochloric acid, if there is one. And then quantitative data, probably the most important part of the report other than the objective and conclusion, would be always given in a table with the units, like in this case all grams, in the heading in parentheses. And you'll notice there's 2 trials here. There are no calculations given in the quantitative data, and there's no results given here. So if you're reporting density as part of an experiment and you had to measure 2 things to get it, you don't report the density here. That's part of your results. Then you want sample calculations of how the data is used to produce the results. And The accepted value here for the reactant to product mole ratio is 1.0, so that's what you would use for any error calculation. Here is what is graphed, and what we're doing here is a series of statistical comparisons. I'll show you how to do that at some time early in the semester. And here's the actual data used from, well, you can see this, looks like a couple of dozen student pairs reported, and that was then used to get the final results and graphs. A graph is given, and this is millimoles of sodium chloride produced versus millimoles of sodium hydrogen carbonate that were used. The subscript here issue, sometimes you just can't do subscripts on particular programs, particularly Google graphing. They can be a little weird, but do the best you can on that. Here are the results, and you can see how that's reported with the units up in the heading. And be careful not to split your tables across page breaks as he did here. The conclusion answers the question raised in the objective. You might want to just read this carefully and see what the conclusion was and that it fits our description of good conclusions. And I added what you see at the bottom. Within experimental uncertainty, the ratio of reactant to product moles is 1.0. Then the extensions, comments on accuracy and precision. You can see what they did here is very measured and doesn't emote on here. So that is a good, if not perfect, lab report. I hope that demonstration helps you when you write your first formal lab report. Don't make them too long.